Hey everybody, today we will do another math problem and we will do some linear algebra or matrix algebra, whatever your school call it. I think the same thing. Some people just call it linear algebra. Some people call it matrix algebra. Technically the same thing. So let's call matrix algebra. So technically the idea is to get some type of system of equations, system of equations and turn the system of equations into problem, into an easy value that anybody can understand, right? Of course, if you are exposed to mathematics, you will be able to understand what is going on. But when you do a project, engineering project, you want numbers. You don't want a bunch of X, Y, and Z's, right? A lot of people don't understand that. So, okay, so basically, turn into system of equations into basic numbers or answers, right? So technically, that's what we do it right here. So the problem that we will do is the following. So the problem that we will do is 2x. So it's 2x plus 3y plus 4z equal to 10. Actually, not 20. 20. And then the second equation is x plus 2y plus 6z equal 36. And the third equation is 4x plus 6y plus 12z equal 48, right? So I don't have the answer for this problem because I made it myself, but we can check if the answer is correct by substituting the values of the problem. If we get x, y, and z, and if we substitute those values over here, is going to be equal, the right side should equal to the left side. That is the beautiful part of mathematics, that when something is making sense, you will taste it, you will see it, and you will see the result. That's the beautiful thing about this. And that's all I can say, right, at the moment. Now, let's start with two different methods. One method is called the Gaussian elimination, and the other method is called row echelon. The row echelon method is basically another method that is sometimes used in more advanced topics of mathematics. This is the first method, the linear elimination or Gaussian elimination. That is I will say the baby steps how to do it in college level, and also the echelon, the row echelon is also, you know, basic, but sometimes that is, some teachers tend to ask those type of questions in more advanced topics. But anyway, okay, so let's get started. Right, so first we look at the problem, right? We have 3 rows, 1, 2, 3, and we have 3 columns. We have a 3 by 3 matrix. A 3 by 3. We have 3 by 3 matrix. Right? So the first step is to, if we do the first method, right? Elimination. That is, we need to, and also it's called the gas elimination, the Gaussian elimination, and also it's called a triangular form, and we will see what is going on here. So it's called a triangular form because you will see a little thing at the bottom over here. You have some beautiful zeros, and then you will have an easy peasy to solve for one of them. But normally, what we're trying to do, if we turn this guy into Gaussian elimination, we will see the beautiful thing, and then we will use the row echelon that follows along with that. Right? Let's get started. Okay. So let's make it sure that we turn this guy into 0. So how we do that? Right. So let me just do it right here. So let me just do what is called an augmented matrix, which is, in this case, taking the coefficients, extracting the coefficient out of this, and put it right here, and put them right here, which is going to be 2, right? 2, 3, 4, 2, 3, 2, 3, 4, and we normally put a bar like this, and we put 20, and then we close the bracket. So that's the first equation. Second equation is 1, coefficient is 1, we have it 2, and we have 6, and we have 36. Third equation, we have 4, we have 6, we have 12, and we have 48. The idea right here is to turn these guys into zeros. If I turn these guys into zeros, as you can see, I have a little triangle right there. That is my first goal. I need to make those zeros. Okay, so let's get started. So, step 1, we want to eliminate these guys, right? Somehow. How do we start, right? Now, what I can do right here is use this equation, apply the change, right? To what are the equations? Right, by using one of them, right? By using one equation, and I am going to use number 1. So this is number 1. This is number 1, 2, 3. Okay, so let's get started. So let me use this equation to do this equation, and this is we call it row matrix method So basically what I'm doing is I'm going to create another equation. I'm going to change this one by using that one. So I can say that you can call this n. I call it n because I am applying to 3. So I said n3 is going to be equal my new equation, right? Which is going to be equal to n, right? So remember, in order to make this a 0, in order to make this guy a 0, I need to subtract. And the tricky part of this problem is that I don't have a negative. When you have a negative and you have a number like, if I had a 4 right here, that would be a eating cake, right? Piece of cake. But in this case, if I had a negative 4 right here, piece of cake, but I don't have it. So what I have to do is, do, right? So I'm going to say that negative r rho 1 plus r3. That is going to be my new equation, which is number 3. Okay, let's get started. Okay, so in this case, I'm going to multiply this guy. I'm going to multiply this guy by -2, right? And I hope that it's clear. -2. I am multiplying that by -2. Multiplying this by a -2. Multiply this guy by -2, right? So what do I get? Multiply this guy by a -2 across, I get, and this 2, I apply the change to this one and that one, right? So I just row 1, so it's going to be n. Okay, so I will not write n3, just do it. So it's going to be -4, okay, -4x, -6y, -8z is equal to -40. I hope that's clear. Now, I'm going to, what is the formula saying? Add to row 3, right? So I'm going to apply that one. So I'm going to do 4, actually just 4. 4x plus what? Plus 6y plus 12z is 12z, right, is equal to 48. Add it together. Piece of cake, eating cake. In this case, you work it out this way. Not all the time we killing 2 birds at the same time. In this case, doesn't always work that way. So right here, this is gone. As you can see, that is gone. The only guy that is having something left right here, which is 4z, right? Adding those two together, and add those guys together, and I got 8. Boom. Beautiful. I already knocked this out. I got 2 zeros in the bottom of this because this one is a 0 now, that one is a 0 now, right? But doesn't always work. In this, it just works. Sometimes you have to do more work in order to get it done. Now, so now I got the first one. I gotta write it down right here. So N3 is equal to what? It's equal to 4C and 8, right? Equal 8. Now, so that will translate at the following. So that will translate at, so remember, the top row stay the same. That doesn't change. So this guy translates to this new matrix, which is 3 and is 4 and that's 20. That stay the same. And then the second row now, as a now, is going to be 1, 2, 6, and 36. The one that we applied the Obama change, right? Yeah, they say that Obama, when he was running for election, he said that he was going to do a change, but he never specified what it was. But now we know the change we apply, right, in this one, which is the Obama change, N3 is equal to that one now. We know. So N3 is equal to 4C is equal to 8, right? Okay. So now we can say that 0, 0, and we got 4Z, which is only 4. And with the Obama change, we got this. Okay, at least we know, right? It would be nice if Obama said this change is going to be equal to that, but no. He didn't explain, he just mentioned a change. Okay, so now we made the change on equation 3. Now our job is to make this one a 0, right? Make that one a 0. Okay, so now let's change this equation and see what we do. Okay, so now, so N2, right? I need to change that. I make the 0. So how do I make that 0? That's a good question, isn't it? Now, it's going to the Obama change is going to take a little different process. So, now I need to multiply this one by negative 2. Once I do that, right? Once I multiply this by a negative 2, the whole thing, this whole row by negative 2, this is going to be equal to, so it's going to be equal to negative 2 row 2 now, right? Negative 2 row 2, negative 2 row 2 plus row what? Row 1, right? Row 1. Okay, so now let's get started. So now that guy is going to be equal to, so writing down the top equation. Remember, I am using the top equation. In this case, I am not multiplying, just adding it to it, right? So it's going to be 2x plus 3y plus 4z is equal to 20. Bottom, I got what? I got this times this, so I'm multiplying this and this. I want to make it clear, right? So multiplying that whole row is going to be equal to it's going to be 2x, right? 2x, and it's going to be equal to negative 2x minus 4y, right? Minus 12 12z, and then minus 72 on the side. Add them together. Now this guy is equal to 0. That guy is equal to negative y. Right? That one is gone. And over here, this one is a negative. So negative is going to be negative 8. Negative 8z. And then this is a negative. So it's negative 52. Okay, so now with the new change, we got rid of this because now this is 0, right? So now the new metric right here is going to be 2, 3, 4. It's going to be 2, 3, 4, and it's going to be 20. And it's going to be 1, 2, 6, 36. Actually, but remember, now we changed that, right? We made a change. We apply the one by changing this. Now it's going to be equal to 52. Right? So yeah. So now this is going to be equal to 52. So it's going to be equal to 0 minus 8 minus y minus 8, but I am not writing that. So basically I'm just writing the matrix. So 8 minus, so minus 1, I'm sorry. Minus 1, 8, and minus 52. Right? Okay. The first one that we got was, so that was a 0, right? This, so 0, 0, right? And then 4 and 8, right? Now, this is the beautiful part of this, because now we have a piece of cake problem. Piece of cake. Now when you get it like this, all you gotta do now is put it back into this form, into the regular form, which is a transformation. So it's a change, right? But at least we see the change. So it's going to be 2. So it's going to be 2x plus 3y plus 4z plus equal to 20. The first row. That doesn't change. Now it's going to be equal to, now I don't have nothing over here, right? I have a negative y, right? And I have a negative 8z, and I have 52, and it's negative. Negative 52, right? And then now the bottom I have 4c equal to what? Is equal to 8. Now you understand why this is a piece of cake. Now I can easily say that 4c is equal to 8 divided by 4 divided by 4 on both sides, and z is equal to 2. Now apply the substitution back and apply it back here, right? So now this is the helpful part, because now in this one, all you gotta do, you don't have to deal with x no more in this one, right? But technically, what you do is basically say, okay, negative y, right? Negative y, that you have, negative y right there, minus 8 times what? 8 times that guy, 2, equal to negative 52. Okay, now you do that and you say y, negative y, so negative y minus 16 equal to negative 52. Add that on both sides, right? And you get y, negative y is equal to 52, right? So you got 52, right? You add in the 16, right, to it. Because you added that 16 to the other side, so plus 16, right? So now you can see that there's a 6, right? That's a 6 right there, and then you have a 4 because you bought a 1, so it's 36. So y is equal to negative 36, right? But you still have a negative sign. Divided by negative 1, divided by negative 1, therefore y is equal to 36. That was kind of coincidence that I had a 36 over there, but doesn't mean anything. So it's a beautiful thing about mathematics that, I mean, that sometimes work like this. So now we have we have two values. We have a z is equal to y is equal to 36, right? Now with these values, let's find x, right? So to find x, we already use the two equations. Now we have the two equations. We had a 0 on it. We already used this two. Now we need to use that one. So in that one we have a 2x, right? Plus 3y plus 4z is equal to 20. Now we know the values now, right? So we have 2x, right? Plus 3 times 36 plus 4z and then but z is 2, right? Is equal to 20. Okay, so right here, right? So you have 18, right? Carry 1. So 18, you carry 1, right? And then that is 9, right? But you carry the 1. So 18. So this one give you 18. You carry the 1. This one you carry this 9. So it's 2 times x plus 1. Oh, oops. Plus 108. Plus 108 plus 8 is equal to 20, right? Now, now what do you do here? So you add those two guys. Those are positive values, right? So this is at 116, so 2x plus 116 equal to 20. Add 116, right? On that side, and you get that. I need to do more room than that. So 2x plus 116 plus equal to 1, right? After you do this mathematics, right? So now you subtract 116 minus, so 116, right? So okay, 2x is equal to 20 minus 116, right? Which in this case right here is 96, right? So you got 96. All right, so 96. I believe it's 96, right? So 2x is equal to 96, right? It's negative. Divided by 2. Divided by 2, right? So now you know that this is going to be equal to 48. X is going to be equal to 48. Negative. Right? So negative 48. Okay, so now, once you get it that, right? Now let's plug it in and see whether I made a mistake or not. So now I am claiming that x equal to negative 48. Okay, so So this is the one method to do it, right? So now let's check this out real quick. Okay, so now we have right here. So right here we have a 2 times negative 48 plus 3 times 36 plus I am using equation, this equation, plus 4 times 2 is equal to 1. Okay, let's see. So, let's see. Here you go. So you add all this together, right? And you get that 20 is equal to 20. That's a beautiful thing, isn't it? Beautiful. So this is a negative 96, right? Back on this negative 96, right? And then you add to that, so you add to that back 108, right? So let me just, so you got right here. So in this case you got negative 96 plus 108 plus 8 is equal to 20, right? So in this right here, you back to 116 plus negative 196, it gives you what? It gives you 20 back again. 20 is equal to 20. That's a beautiful thing. Beautiful. Now, so we know what we got doing that method, right? We know that. Using the Gaussian elimination. The Gaussian elimination. Now, let's do the raw echelon. The raw echelon. The raw echelon is going to be, it's the same thing. We already did part of it, right? We did part of it, right? So we turn these guys into zeros, right? We got a little triangle right here. That is zeros, right? Now, our goal is to make this guy a 1. If I can get another marker, that helps, so you can see it better. So make that a 1. This one a 1 because technically right now it is a 1, but it's a negative 1. See, that's the difference. We need to make this a positive 1, and we need to make this a positive 1. Once we have zeros and we have 3 zeros and we have that diagonally ones over there, we call that row echelon form. Row echelon form, right? Let's do it. Okay, so how do we do that? That's the question. So the question is, how do we do that, right? And this one is called the pivot. This one right here called the pivot number. Now, what we can do now is the following. So we need to make this a 1, but the question is how? Well, we know a little bit of mathematics, right? So again, back to common sense. We know the values. We need to get the same answer by using the row echelon. Okay? So By using the Gaussian elimination, we found that. Now, in order to get this, so it's equation 1, right? In order to get that 1, so I need to multiply all, because people get confused in this. They said, oh, 1/3. They said, oh, I can get a marker that works. 1/9 times 1/3. But is it really? Isn't that the same as mine divided by 3? Yeah, the same thing. Yeah. That guy is being multiplied by that. So it's technically 9 over 3, which is 3, isn't it? Okay, never mind. So I don't want to confuse anybody, but we need to follow some little trick over here to get rid of that 2. Now, so let's do this. Let's do this. So let's do this. If I have a marker that works, that would be great. So let's see. 2, right? 3, 4, and then 20 this side. Okay, so I need to make this guy a 1. I need to make this guy a 1. How do I do that? Well, multiply it by 1/2. That's a 1. But if I do that to that, it's going to be multiplied by 1/2, which is divided by 1/2 in that one. Divided by 1/2 in this one. Divided by 1/2 in this one, right? And that is equal to 2, right? And of course that is 10. Okay, so now we apply another change, another Obama change to the matrices that we do, to apply into the numbers that are not zeros. We apply a change. Okay, so now this is going to be looking like this. So it's going to be looking like this. So it's going to be 1. It's going to be 1. These markers are not really working. So 1. Okay, so it's going to be 1, right? That one is going to be 1, right? So this one is 1. 1, right? And then 1. And then that one is 1/3. And then that one is 2. And then this is, okay, so this is 2, this is 10. I don't want to confuse anybody. 10. This is 10 now. Okay. Now, we say that we want to change this guy because of what? Because it is a -1. It's not a 1, it's a -1. And we have to follow rules in mathematics, unfortunately. So, what do? Divided by it. Divide or multiply, isn't it? Isn't it both the same thing? Time, negative times a negative, they give you a negative times a negative give you a positive, and negative divided by a negative also is a positive. So either way. So we can actually do this. Right, so dividing this by -1 over -1 will eliminate this, but it makes you change that. It will make a 1 by changing this one and this one. It will make that a 1. So applying that is going to be the following. So apply that change is going to be a 1 right here, right? A 1, right? And it's going to be a negative, but it's going to be, well, it's going to be a 0, I'm sorry. 0, but that's going to be a 1. But the 1 by change is going to be applied to that one. So in that one, it's going to be a positive 8. Positive 8. And this 52 also gets affected by that Obama change, and that is going to be a positive 52. Right? Now, so the bottom one is also a 4th, right? So how do I change this to a 1? Well, divide and multiply it by 1/4. That will cancel that guy out, and that will going to be a 1. And of course, this is going to be a 2. See how beautiful this is working out? See how beautiful this is working out now. Now this one it's going to be a change. So this one, right? So now it's going to be a 0, 0, and this is a 1 now because it's getting multiplied by 1/4. It's going to be equal to 1, and then last but not least, that 8 is being multiplied by 1/4, which is technically 2. Now, it's even easier to say the answer. See? If you write this in the metric forms again, you will see the following. You will see something like this. You will see the only goofy part is this one. You got a little fraction. But you can work it out, right? So you got right here, you got an x. You got an x, you got a plus 3/4, I'm sorry, 3/2. 3/2 y. And then we got what? We got plus 2c. And then that is equal to 10. Okay, and then we have y plus 8z plus 52, right? And then we got a z is equal to 2. See, we don't have to do anything right here. In this case, matter of fact, we don't have to do anything, just already solve for us. Right? I mean, C is already solved, but we need to do the rest, right? So now let's do this. Okay, so let's substitute that guy into here to solve for y, isn't it? Isn't that beautiful? So y plus 8 times 2 is equal to 52. 8, right? So now this is 8. This is 16. So y plus 16 is equal to 52. Move the 16 to the other side, right? Move the 16 to the other side. And then, so you borrow that, right? So you subtract this from this. Isn't that 46? So now we prove that by row echelon that y is equal to 36, and also C is equal to 2. Let's knock it out. The last one. Using the raw echelon. Okay, so using the raw echelon, let's knock it out. So now, right here, let me just do this. Let's use this first equation, the goofy one, right? The one that's 1/3 on it. So let's use that one. So in this case, we're going to do 1 plus 1/3. Oops. Nope. It is 3/3. It's goofy. Yeah, it's an improper fraction. 2 plus, okay, so this is x plus 3/2 y, right? Plus 3/2 y plus 2. 2z is equal to 10. Beautiful. Okay, so we got the following. So we got 3, right? And then we have right here, we have a 3, right? But y is what? Y is, we say that y is 36, right? 46. Right? And this is everything divided by 1/2. Plus 2 times what? I claim that the 2, the c is equal to 2, and then that's with the change that we apply is equal to 20. Okay, I'm sorry, 10. Okay, this is 18, right? This is 18. Let's see. This is 8. Yeah, this is 18, right? So that's 18. If I cancel that, so it's 18. Right? Now, right? Now 18 times 3 is equal to 54, right? So then I got what? I got x plus x plus 54 plus 4, right? Plus 4 is equal to 10. 54 plus 4 is 48, right? Move to the other side is what? I'm sorry, 54 plus 4 is 58. Move to the other side is what? 48. Negative, right? Because you move this to the other side. So technically, it's 58. 58 is equal to 10, right? But when you move that, when you move this to the other side, this becomes 10 minus 58, which is equal to negative 48. Right? Negative 48. So we got that x, by doing this, x is equal to negative 48. So we prove it by using the two methods. we prove it that using the two methods, that using this method, which is a little more work, I mean, you don't have to do this, right? You don't have, I mean, if the teacher doesn't require, I mean, this is just to make things more presentable, I guess. You know, when you have a bunch of these ones right here, they look beautiful, I guess. And then you have a bunch of zeros. So, look like a little triangle. And that is, so, okay, so let me just, somebody asked you for the answer, and in this case, all you gotta do is leave it like this. So, parenthesis like this. So x equal negative 48, comma, y is equal to 36, and then z is equal to 2. If I can get a marker that's helping out. Right? So that is the final answer. And we prove it by using both methods, the row echelon and using the Gaussian method, the Gaussian elimination method. Thank you for watching. See you in the next video.